Good morning, class. Today is Thursday, May 11th. Let's begin with some math. So as we started a few days ago, we are going back through our Ultimate Math books, and we are attempting pages and worksheets that we hadn't finished earlier in the year. I cannot say this enough. Your Ultimate Math book is your book. And if it were me and I wanted to be the best prepared I could be for middle school, I would take some time, even just 5 minutes a day, and either do problems in my Ultimate Math notebook or go on iExcel, because really practice makes perfect, especially with math. And if I have to say one thing, practicing things like place value, multiplying, dividing, adding, and subtracting with decimals, with fractions, with whole numbers, all of that is probably the most important. So if you have time now, if you have time over the summer, and no one can say they don't because we're all at home doing nothing, make sure that you are doing a little bit of math every day. I know my mom used to make me calculate like the sales tax and things like that when we go to restaurants or stores and things like that. So even as we're going back outside, there's plenty of places for math to be all around us, and make sure that you're practicing. And the extra pages, the empty pages in your Ultimate Math notebook are a great resource for you, especially if you don't have a good computer at home to use for math practice. All right. So that's enough of my soapbox and my public service announcement. We are on page 19, which is talking about base 10 system and place value. Let's sing our song together. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, and tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. Just as a quick place value review, remember, if I have the number 2 and 4/10, okay, my and tells me that this is the place in between my whole numbers and my parts of a whole, or my fractions and decimals. That's why I'm saying and. This way we have our whole numbers. This way we have our decimals. Remember, anything that ends in the TH, remember we said we spit, that's going to be our fraction, tenths. Now, if I wanted to show how much this was in tenths in general, so say I want to say 2 and 4/10, just using tenths, this is just like asking myself, how many dimes would I need to make up this number? So if you think about it that way, how many dimes would I need to make up $2.40? Remember, I can add a smiley face 0 here because it doesn't matter. It's not in my decimal sandwich. So how many dimes would I need to make $2.40? Each dollar has 10 dimes. That's 10, 20, 24. Oh, remember, I can just move all my numbers over to this place value, get rid of that decimal, and that would tell me how many tenths I need. So 24 tenths. That's just kind of a review before we get started. So for this blue square, it says for the next 5 questions, refer to the number below. So number 1 says, what is the digit in the trillions place? Number 2 says, which digit is in the 100 millions place? Number 3, what digit is in the 10,000s place? Number 4, what digit is in the billions place? Which digit is in the 10 billions place? The next set says, write a digit that meets the criteria for the questions below. Number 6, the following digits are used to create the number 2, 3, 4, 5, 6, 7, 8, and 9. In the tens and hundreds places, there is a composite number. Ooh, we practice this every day for a really long time, so I hope everybody remembers what a composite number is. But in case you don't, erasing. A prime number is a number that only has 2 factors. Remember, a factor is just one of those things in a multiplication question that we get to get the product. So it is a number that can only be multiplied by 1 and itself to get that number. So an example would be like 3. The only way I can get 3 is 1 times 3. There's no other multiplication sentence with whole numbers that could get me 3. A composite number, puppy, what are you doing? Okay, mis amigos, we are back from fishing the TV remote out of the dog's mouth. Things I didn't think I would say while teaching ever, but here we are. So Like I said, a prime number is a number that can only be multiplied by 1 in itself, like 3. A composite number is one that has more than 2 factors. More than just 1 in itself can be multiplied to get my answer of 4. So for example, for 4, we have 1 times 4, but we also have 2 times 2, okay? 2, by the way, is the only even number that is prime because it can only be multiplied by 1 to get its number. So that's just a little review. I know we've talked about that a million billion times, but just in case you forgot. So it says, and in the tens and hundreds place, notice it says tens and hundreds, not there is a composite number. In the ones place, there is a prime number. In the hundred thousands place, there is a prime number. All other digits may be arranged in whatever order you like to create the largest number possible. So remember, we're going to want our bigger digits like 8 and 9 to be further to the left. Number 7, the following digits are used to create a number: 5, 6, 7, 8, 9, and 0. What is the largest number you can create using these digits only twice each? Let's talk about these answers. So you can pause on this page, make sure you're going through those answers. Number 1 is 0, number 2 is 1, number 3 is 0, number 4 is 7, number 5 is 4. Number 6 is 98,753,642. And number 7 is 998,877,665,500. So now we're going to do our black diamond. Write each number below, then use it to answer the questions beneath. So this first one says 452,904,620,042,826. So the first thing you need to do is write out that number. Then you need to use that number to answer the questions 1 through 5. So number 1 says what digit is in the quadrillions place. Number 2 says what digit is in the trillions place. Number 3 says what digit is in the 100 billions place. Number 4 says which digit is in the 10,000s place. Number 5 says which digit is in the tens place. Number 6, I am thinking of a number. I love these kinds of problems because they feel more like a puzzle than like actually doing hard math, even though it is really difficult and even though it is math. If you add together all the digits of this number, it equals 25. The tens place has a digit that is equal to 3 squared. The hundreds place is 1/3 the tens place. The ones place is 1/3 the hundreds place. The thousands and 10,000s place feature a prime number. None of the digits repeat. The 10,000s place is smaller than the thousands place. What is my number? Okay, so a couple things that I want to decompose there. First of all, when you're given a question like this, that's giving you a specific place that a digit needs to go, make sure you draw out and you put commas between your places, almost as if you're playing Hangman or Scrabble or something. So let's do kind of the first part of this together. So it says, if you add all the digits together, it equals 25. I think that's the easiest thing to miss because it comes first. The tens place has a digit that is equal to 3 squared. So remember, we write 3 squared like this. 3 is my base, 2 is my number of pi. This does not mean 3 times 2. What this means, it's 3 multiplied by itself this many times. So what this actually equals is 3 times 3, like so. So in our tens place, we need to put 3 times 3, which is 9. So we go, I'm trying to think how I would do this. You want to put it in the tens place, which I think is here, but it's hard for me to tell backwards. Yes? No? Yes? Yes, that's correct for your direction. Place value is hard backwards. So kind of fill in the rest that way. Make sure you use the Hangman Scrabble technique. Number 7, I'm thinking of a number. If you add together all the digits of this number, it equals 28. None of the digits repeat. There are no zeros in my number. My number is the largest possible number that could meet these criteria. So answers. For number 1, it's 452, 904, 620, 042, 826. That is a mouthful. Number 2 is 0. Number 3 is 2. Number 4 is 9. Number 5 is 4. Number 6 is 2. Number 7 is 57,391. And number 8 is 7,654,321. The temptation with number 8 is to try to fit that 9 and that 8 in there. But keep in mind, I'm going to get to my number 28 much faster if I'm using those bigger numbers. And what matters here is that we have as many place values as we possibly can. Okay, so that is all that you're required to do for today. If you want to do the double black diamond instead of IXL, that's what I'm doing next. So you don't have to do the double black diamond, only if you do not wish to do IXL. So our double black diamond says write a number, but these are more like puzzle types. So they're kind of fun. Number 1, write a number that is exactly 400,000 greater than the greatest number that can be formed with the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 without repeating. Let's do this one together. So what is the biggest number we can create with all those digits? Keep in mind, it says we can't repeat it, so we know how many places we're going to have. We're going to have, did it include the 0? Yes. So we're going to have 10 place value digits. So everybody draw on your whiteboard, on your piece of paper, in your Ultimate Science notebook, 1, 2, 3, 10 dashes, 4, 5, 6, 7, 8, 9, 10. And then let's add a comma in between each of those digits. It's like so hard for me to do this backwards. Oh my goodness. I'm going to die. Not really. That was a hyperbole because I was exaggerating to make a point. Yes, this is correct. Nope, I did it backwards. Give me a second. 3, 3, 3. Okay, hopefully this is appearing correctly now. Awesome. So now I want to put my biggest digit furthest over so that I can create the largest number, right? So I want to put my 9 in the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. So I want to put my 9 in my billions place. Why do I want to do that? Because my 9 is my biggest digit and I want to put it furthest to the left so that way it has the greatest place value. It's in the billions place. 9 billion is 8 billion more than 1 billion if I put it here. I then want to put all my numbers in decreasing order. Three, 2, 1, 0. So I should first get a number that looks like this. But now I need to add 400,000, okay? So remember, I need to line it up still. So this is, thousands, 10,000s, 100,000s. So I need to go 400,000, like so, and add it up. Another way of doing this is just looking that 5 plus 4 is not going to go over 9. So this number here just becomes a 9. And this is my final answer, right? Because 5 plus 4, remember when we're adding those place values, I can ignore all these zeros because they're just going to equal 0 and just add these two places together. Key thing here is lining it up at the decimal, like so. So this is my actual answer. Let's count it out together. So thousands, millions, billions, 9,876,943,210. Pretty cool, huh? Number 2, write a number that is exactly 1 million less than 300 trillion. Number 3, write a number that is exactly 400,000 less than 1,760,000. Number 4, write a number that is exactly 1 million less than 700 billion. Number 5, write a number that is exactly 200,000 less than the largest number that can be formed from the digits 1, 2, 3 repeated twice. Let's take a look at our answers. Feel free to pause on this screen for a second. So congratulations if you did this work. It is really hard, but it is also just kind of a fun puzzle. If you did the double black diamond, remember you do not have to do the IXL. Just push yes anyway. Thank you so much for joining me for math this morning. I know that today is a pretty math-heavy day, so get yourselves ready, but then tomorrow's the weekend. So congratulations. And I'll see you in a little bit for science.